Chapter 6 is about random variables. So here for section 1, we're going to talk about two types of random variables. The first video will be about discrete random variables, and the second one will be about continuous random variables. So our learning targets for this will be using a probability distribution of a discrete random variable to calculate the probability of an event, making a histogram to display that distribution and describe its shape. And then we will also calculate and interpret the mean, which is called the expected value, and calculate and interpret the standard deviation. So remember that a probability model is one that lists out all the possible outcomes along with the likelihood, the probability of that outcome. So for instance, if you are tossing a coin 3 times, here we have our sample space, right? All 3 times it's tails, heads, tails, 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 heads, tails, so on and so forth. Well, what we do is we're going to introduce this random variable. We're going to call it x. It's kind of like when we did probability in chapter 5 when we said let x be the number of heads, right? What's the probability that you get 3 heads? Things like that. So here x can take on multiple values, 0, 1, 2, and 3. So we list out those outcomes and then the probability of each outcome. So a discrete random variable is one such that it's only taking on unique values. It's not any value in between these. So when we're talking about the coin, 0, 1, 2, 3, depending on how many tosses, you can't have half of a heads, right? That doesn't make sense. So that's how we know we have a discrete random variable. So just like before, all the probabilities have to be between 0 and 1, and they must add all to be 1. So here is the example from, I think it was back in chapter 1, about the APGAR score. That's a score for babies, about how healthy or well they are when they are born. But anyway, so their score, you can either get a 1 through a 10. You can't get 1.5, 2.7, none of those values, but strictly the integers. So here is their score, and then you have the listed probability. In the past, this has been a frequency graph, but here we have a probability distribution. So whenever you describe the distribution, remember that you're always thinking about that acronym of SOX, right? You need to talk about shape, if there are any possible outliers, the center, and the spread. Another thing to remember is your measures of center. You have the median or you have the mean. And when you talk about the spread, if you use the median, the spread should be the IQR. And if you use the mean, then we should use the standard deviation. All right, so here's just an example with Pete's Jeep Tours where they offer a trip. There must be at least 2 passengers. They can hold up to 6. It's $150 per passenger. So C is our random variable. We're going to let it be the total amount of money Pete collects on any randomly selected trip. So here is the probability distribution. Remember, it is money. So this is 2 passengers. It's $300, right? 2 times 150. 3 passengers, 4, 5, and 6. And then it already has listed out the probability of each of those scenarios. Then all we do is take that information, put it into this histogram. Remember that when you're doing graphs, you must label your axes. Okay? And then it says describe its shape. So here this one's fairly symmetric. All right, so how do we calculate the average or the expected value of a discrete random variable? Remember before, you would just add all the values together and divide by however many there are. But in this scenario, you don't have necessarily all the values listed because it's not, oh, I'm going to flip it this many times. What's the average number of heads that I received? That's not what we're looking for. This is over just a long period of time. And each outcome has a different probability associated to it. So in order to find the expected value, you take each value that the chance process can have, and you multiply it by its corresponding probability. So you take the x1 value, the first value, multiply by its probability. Then the second value by its probability, so on and so forth. Then you add them all together. This formula is indeed on your formula chart, but only this part that I've highlighted is what you see. Okay, you don't have this summation written out. The x1 p1 plus x2 p2 plus x3 p3. That you need to know that sigma is summation. Okay, that means I'm adding things together. And then we have xi, pi. So when we're talking about the first value of x, we're talking about the probability, the first probability for x as well. That's where you get all of these expressions. So this uppercase Greek sigma means summation. Again, this is in your formula chart, but you need to know how to use it. So for Pete's Jeep Tours, here is our probability distribution. Remember, the cost of 2 passengers was $300, and the probability of that, I believe, is 0.15. So on and so forth for all of these. And you're essentially finding the area of each of these rectangles when you're doing the value times the probability. But it comes out to be $562.50. So what does that mean? It's if we randomly select many Jeep tours, Pete will make about $562.50 per trip on average. Remember that the mean, the average of a data set, is the balancing point, meaning that you have equal weight on one side versus the other. Median does not take into consideration the value of the number, it's just strictly the middle number. Alright, so here's just another example of how to do that. So let's talk about variability, finding standard deviation, or also variance. This is something that we will be doing in our calculator, but it is very important that you understand how it is calculated, because I have seen on an AP exam where the answer asked, or the question was asking, what is the standard deviation of the random variable? And instead of giving the final decimal value of the standard deviation, they gave part of the process as the answer choices, so showing how you actually calculate it. So it's the same or similar process as we did in chapter 1, where you're taking the sum of a bunch of values. So looking at our formula here, you're taking the x value and you're subtracting the expected value. Remember, this is expected value, the average. Then you square that difference and you multiply by the corresponding probability. So you do that for the first term, or the first value, the first possible outcome, and the second, the third, so on and so forth. Add them all together. When you just add them together, this is giving you the variance. But then when you take the square root, that is when we get the standard deviation. Again, this is in on our formula chart, but it's good to know how to calculate it. So here for the APGAR scores, we would have seen in the previous example that the expected value is 8.128. So calculate, interpret the standard deviation. So we take the x value, 0, we're going to subtract the expected value, then we're going to square that difference, and then multiply by the probability of the value of 0. Then we're just going to rinse and repeat for each possible score that the child can get. We're going to add them all together. So the variance is 2.066. And then when we take the square root of that, we get the standard deviation, 1.437. So what does that mean? It means that a randomly selected newborn baby's APGAR score would typically vary from the mean, which is 8.128, by about 1.437 units. So just remember, everything that we've done up to this point are for discrete random variables.